Hello everyone, this is PEEPanEIP, the one and only podcast where we deep dive into Ethereum improvement proposals and the latest development in the Ethereum ecosystem. I'm your host Pooja Ranjan, and today we are diving into an exciting proposal 7587 Reserve Precompile Address Range for RIPs. We are joined by a very special guest who is also one of the co-authors of the proposal. So stay with us as we explore EIP 7587 for Layer 2 solutions. Welcome back to PEEPanEIP, episode 134. Proposal documented in December 2023, EIP 7587 is a meta proposal that aims to streamline and future-proof Ethereum's development by reserving specific address ranges for precompiles and is currently in the last call. Joining us to unpack this proposal is none other than Tim Beiko, who is the ACD meeting facilitator and one of the co-authors of EIP 7587. Thank you, Tim, for joining us here today.
Thank you for having me.
Well, Tim Beiko is a name that needs no introduction in the Ethereum ecosystem, but we will be interested in learning more about your role at the Ethereum Foundation, how you got involved with Ethereum, and you have authored multiple proposals. So it will be nice to hear about EIP process and overview and anything that you would like to share with our community to encourage more people to get participated with the Ethereum ecosystem.
Yeah, well, maybe to start with how I got here and what I do now. I started off just as an Ethereum user. So I heard about Ethereum in 2016 and started using it. And the experience just really wasn't great. A lot of times, if there was like a popular application, the mempool would stay like clogged for like hours, if not days. There's all these things like around UX and around like understanding what's actually happening on chain that just were not super intuitive. And so I decided I wanted to work on the protocol because even though like the applications on it were all kind of new and experimental, and I didn't necessarily want to work on a single one of them, it seemed clear that like Ethereum as a whole would stick around, and I got really interested in that. At the time, I was a product manager, and Ethereum is not really a product. It wasn't really like a role that existed. That was what I wanted to do, which was like work as a PM on the protocol. So it took me a long time to actually get a job working on Ethereum. I spent probably a year just reading things online on like Ethereum Reddit and other places and keeping up with everything around the community. And then actually I decided I would attend ETH Berlin and I would attend DEF CON and I'd try to find a job there if nothing else worked. But I got lucky that a couple months before that, Consensus started their own client teams. So the Besu team today, and they needed product managers for that. So I managed to join the Besu team as a product manager, and there I was working on the mainnet implementations for Besu. So everything around the EIPs, but also anything to do around like performance optimizations and whatnot on the client. And so I started attending the core dev calls as part of that, and did that for a couple of years. The person who was running the core dev calls while I was there was called Hudson, and he eventually just left and moved on. And so when he left, I was basically the only non-engineer who would attend most of the core dev calls and then had like some context around what was being discussed. So I basically took over from him, and now since 2021, I've been running these core dev calls for Ethereum. And the core thing that I do there is basically help us plan and execute on network upgrades where we decide which EIPs we should work on and then actually work on them, test them, and eventually deploy them.
Very interesting. I think you attending the Berlin session, not only you got lucky, even Ethereum got lucky that we got you, and you have been facilitating all core dev quite well. We made so many upgrades here, and I look forward to see many more upgrades coming to Ethereum ecosystem.
Thanks. Yeah.
Welcome again. I understand there is a presentation, so without further ado, let's peep in.
Sweet. So, okay, this is a bit of a unique EIP. So I'm going to talk about the EIP-7587, which reserves precompile address range for RIPs. And most of this presentation will actually be about unpacking what this means because the EIP itself is quite simple. But in short, yeah, let me start by saying, like, explain what precompiles are. And the way to think about this is on Ethereum, we have functionality that we want the EVM to be able to process, but that's too complicated to implement in EVM code directly. So we can't use like the opcodes that exist in the EVM to do them. But there are these things that are really important that we still want to be able to do. The main example of this is cryptographic signature verification. So if you think about signature verification, you have like a public key and a signature, and you want to verify it matches some private key. You need to do a lot of computation to do that. And implementing this in EVM using assembly or Solidity is just too expensive. So we have this concept of precompiles, which are these contracts on Ethereum, but the only thing that's defined is what the input should be to those contracts and what the output should be. So for example, like some public key, some signature, and then the output should tell you whether it's a valid or invalid signature. And what happens is that the code that's executed is left up to the actual client developers. So for example, I worked on Besu. Besu uses Java to build the client. And the way that it would do a signature verification precompile is it would just get those inputs and then call an external Java library that does the cryptographic operations, returns the value, and then expose that back. And Besu can do this with a library that's optimized in Java for its own client. But if Get has to do this as well, they can take a library in Go that's optimized for their own client, and so on. So basically, the idea with precompiles is that by only defining the inputs and outputs, we give client implementers the flexibility to find like a high performance library to evaluate those functions that are just too complicated to like evaluate in the EVM itself. And so today on the Ethereum mainnet, there's 10 precompiles, and we've basically deployed them at the addresses 1 to 10 in hex. And when we say deploy, the way a precompile gets deployed is not like a regular smart contract where anyone can deploy it. It's more that when we have a network upgrade, we say, as of this upgrade, this address now runs this code. So it requires a hard fork basically to deploy. It's not something just anyone can do. And so we have these, again, mostly to verify cryptographic operations, but just generally process these complicated functions that can't be done in the EVM and where there's libraries that are specialized that clients can use. And so I said there's 10 precompiles. These are the lists. If you're ever wondering what's in the EVM or what's in precompiles, evm.codes is an amazing website. I don't know who maintains it, but I love it. I use it all the time. And you can basically see like the first one is this recovery of a signature. Then we have hash functions, one identity precompile that just returns the same value that's passed to it, and then a bunch of other like either like expensive mathematical operations or hash functions. And then the latest precompile that we added to the Ethereum mainnet is this point evaluation precompile 0x0a. And this is the precompile that verifies the data in blobs. So when we say that we verify the data, what we mean is that anyone can take a data from a blob and then use this precompile to make sure that the data actually matches a blob that was published. And by doing this, we're able to only keep the hashes on Ethereum's execution layer. So you can always verify proofs against those hashes, but you don't need to have all the data on Ethereum's execution layer. And one last thing I'll just add in terms of like the addresses. So the way it's portrayed on this picture shows 0x01, but it's all like buffered by zeros. So the actual addresses are like 0x000000, and then the last digit is 1, and so on. So this is precompiles, what's deployed on mainnet already. And then one thing over the past couple of years is we've seen L2 start to deploy, and then they tend to want to have their own precompiles for a bunch of reasons. But in general, it's like a similar idea. There are these operations that maybe have a lot of off-chain processing that are just useful to the L2 that need to be deployed. And so L2s have started to deploy their own specific precompiles. The screenshot on this page is from Arbitrum. But if you look on Optimism, for example, their docs have a whole section around like, if you're deploying your own Optimism chain, how can you add your own precompiles? So we see that like, even though mainnet has like the set of operations, L2s want to do more of them, and they have already in practice. And in the past year as well, one thing that came up is if we have these L2s that want to implement new features, how should we standardize this, right? Like if there's a specific precompile. So for example, we have one here that's a new cryptographic curve that's not supported on L1. A lot of L2s would like support for this. So it would be nice if this was done in a standard way so that if you use Arbitrum and Optimism and you're using this curve, you can just copy paste your contract from one to the other and you don't have to think about anything. Or similarly, if you're like a wallet and you want to integrate with this curve, you know that it's always at the same place. So the RIP process, or Rollup Improvement Proposal, is this process that came up to try and like standardize things that should be deployed across multiple L2s, so that aren't like specific to Optimism or Arbitrum or any other chain. And so if you combine these two things together, where there's like these precompiles that are deployed on L2s, and we want to do this in a standardized way, one thing that we want to think about is like, where do we deploy these precompiles? And this is where EIP-7587 comes in. The EIP basically just proposes that we reserve a range of addresses on Ethereum layer 1 and say, all of these addresses, L2 should not deploy precompiles here. It's possible that L1 will eventually deploy something there, but then we also reserve another range that L2s can use to deploy precompiles. And this is valuable because, yes, like we avoid L2s deploying something and then L1 deploying something at that same address after. And then you could also imagine something where an L2 precompile gets deployed to L1 in the future, and we might want to reuse that address on L1. And there's pros and cons to doing this, because if we have the precompile used on L2s and we deploy it on L1, if we ever need to change something about the precompile and then it behaves somewhat differently on L1 than L2s, this could be really problematic if it uses the same address, because now you have contracts or wallets or whatnot that expect some behavior, but there's a different behavior happening. And then the other obvious thing is that, yes, if there is like a precompile that should be deployed across multiple L2s, like this one we talked about, the R1 curve with RIP-7212, L2s can just choose, okay, which address do we deploy this on, and have like an easy way to coordinate on that. And so in practice, the thing we've done is we've reserved the first 256 addresses for L1, or sorry, 255 addresses for L1, because we don't deploy to 0x0. So the L1 precompile range is from 0x01 to 0x0ff. And this is the hex notation, but in decimal, that's 1 to 255. And then the next 256 precompiles after that are reserved for L2. So 0x100 to 0x1ff is the range that's reserved for L2s. And like we saw earlier, L1 had like 10 precompiles in about 10 years. So we have like 250 slots. We're good for a very long time. And on L1, we've also tried to move away from using deep precompiles when we can. So for example, the Beacon Chain deposit contract is not a precompile. It's just a random contract that anyone could have deployed. And same for EIP-4788, which gets us state root from the Beacon Chain on the execution layer. This has been deployed also as a regular contract. EIP-2935 is going to use a similar model. And the sort of philosophy there is that if there are things that we can actually do in the EVM, we should do them that way rather than using precompiles. So we really want to restrict precompiles, at least on layer 1, to things that are basically impossible to do in a computationally efficient way through the EVM. And there's even some research that's being done about how do we improve the EVM's ability to do complicated cryptographic operations. So EVM Max is a big area of research there, where people are trying to think about extensions to the EVM that would allow us to possibly even remove some of the precompiles we have today and replace them with EVM code. And the reason why we'd want this is it's just kind of nice to be able to like inspect directly on chain the entire thing, right? Whereas if you have a precompile that's not like deployed on chain or anything, you have to trust that like, okay, given these inputs, I get this output, but you can't really see what every client does. And this is something that's at risk of creating consensus issues. So if we all have the same code that we know is running, that simplifies things a lot. So we're not quite there yet, but there's some work being done to make the EVM more amenable to that. And then another just like thing to note about this range is that L1 has the first range, which makes sense because the first precompiles were deployed on L1. And then the L2 range is also easy to extend, right? Like, so we have 256 slots there, but if we wanted to extend this in the future, we could just make it bigger. And so that shouldn't be too much of a problem. My last slide. So this is a bit of a weird EIP I said at the beginning. So 7587 is not a core EIP. It's not like a protocol rule. If you launch, like an Optimism chain and you deploy a precompile in the wrong range, nothing bad, quote unquote, is going to happen directly on your chain. But the idea is to have this social norm that splits things so that if you actually do deploy something, then the tooling can know that, okay, this is like an L2 precompile and we should expect every chain to have this. And we should also expect that if there's something here on this chain, on L2, there won't be something here on L1 and vice versa. So that following this norm just gives us much better assurances when we're building toolings and deploying contracts and whatnot. But again, there's no like in protocol rule that checks, is this address a precompile, yes or no, or anything like that. And so that's all I had. Again, it was a pretty simple EIP. Hopefully the context was useful. There's a couple people on here. I'm happy to answer questions if anyone has them.
Great presentation. Yeah, you really explained a lot of things. You explained about precompile. You also answered a trivia question that how many total precompiles are there on the mainnet for Ethereum? Thank you for that. Maybe we could use it in some event. And you talked about rollup improvement proposal and also shared about the addresses reserved for L1 and L2. As some of us may already know that we are expecting an EIP version of RIP-7212 in the Petra upgrade. So I would recommend people to maybe go ahead and check episode 129, which is specific on EIP-7212 with Ulas to learn more about the first rollup improvement proposal, which is going to make use of this proposal and will be included in the Petra upgrade. Coming back to today's discussion about the reserved precompile address range, Tim, I would like to understand here about the community response because this is not a core proposal. It will not be deployed with an upgrade. Of course, proposal 7212 will be making use of this. So for a meta proposal to get a community consensus, it is important to respect their feedback. I want to understand if there were any major blockers, support, or anything specific that we have received from community feedback that may have been implemented on the documentation of this proposal.
So I don't think there was any negative community feedback as far as I can tell. Hopefully I'm not missing something. As you mentioned at the beginning, this happened like a while ago. I think we drafted it in 2023, right? Yeah, I think in general, like it almost felt more like something to accommodate the broader RIP process, right? So like, yeah, we wanted to do 7212, and then the question came up around where should we deploy this? And that sort of led to this proposal. But yeah, it's a pretty simple thing. So I'm not aware of any like pushback or oppositions. Yeah.
As a ACD coordinator, if you're suggesting that there were no pushback, we take you by your words because the decisions are generally made on the ACD calls. My question here is more specific towards the type and category that we would decide for it, as well as the status we would want to see this proposal. Following the comment there, I read a suggestion from the community member that it could be a living proposal, but the proposal currently is in the last call status, meaning it will be moving towards the final status. Do we not see the reason to have it in living because we have already allocated enough room for RIPs and L1 projects?
Yeah, I think we should, one, minimize the amount of things that are in living. Like, I think this is a pretty big range, and I would prefer that if we exceed it for whatever reason, we make a new explicit decision, and we could just have a new EIP that says, extend the precompile range and saying, okay, it goes from like 1FF to whatever, 2FF, or like maybe 10 times more. Like, and I think, yeah, we'd want to understand the context of like, why are we extending the precompile range? Because as we've been using precompiles today, we're probably good for 50 years with this. So there'd have to be like a sort of a qualitative change in how we use precompiles, especially on L2s. And then I think that warrants its own proposal rather than editing this. Yeah.
Of course, 50 years is quite a decent timeline that we can look for Ethereum. If Ethereum sustains for another 50 years, we are good with that. I think it will be a problem for developers at the time. Very well. I understand what we are trying to do here is like make use of all the blockchains to support each other. We are talking about layer 2 proposals, layer 2 chain, and Ethereum supporting them. Considering this as a social norm and maybe sharing this as a warning to other chains who are planning to maybe use Ethereum tooling, it means that we are trying to create a room for interoperability and support to each other. I would be interested in learning about your take on the future of interaction between EIPs and RIPs evolving over time.
I think there's a lot to unpack here. I think it would be good for RIPs to try and be as close as possible to how core EIPs work. But that said, it's possible that there are changes. And the most notable thing is that core EIPs have to be deployed by everyone at the same time. So everyone sort of reviews them in a similar cadence, and we find bugs, we fix them, and whatnot. Whereas RIPs are always going to be kind of optional by definition. And for example, take the R1 precompile that's being proposed. Maybe Optimism and Arbitrum reviewed it today and they decided to implement it, and they're all happy about the spec. But there's a new L2 that shows up in 3 years, and they think like, oh, here's actually a better way to implement it, and we did it this way, and it's so good that even our Arbitrum and Optimism agree to that. It feels like there needs to be like this process where there's almost like an in-between stage before final on L2s, which is like a few L2s have implemented it, or like one L2 has implemented it. And it would be nice if it could eventually be finalized, so that if we want to actually move something to mainnet, so say 7212 gets deployed to L2s and then we move it to mainnet, my personal preference would be that like whatever spec we use for mainnet is effectively the same thing. And maybe we change the address, maybe we don't, whatever, but like you should always be able to like copy paste the thing over. And this I think is good because it helps people familiar with the process like understand the whole thing. It's really hard if like the L2 process is really different from the L1 process, then it means L1 devs can't really like follow what's going on and understand it easily. And then similarly, L2 devs, when they want to get something from L2 to L1, might feel like, okay, we've like done all the steps, but if their steps are completely different than the L1 steps in the process, it might not translate over. My general philosophy is I'd like them to be as close as possible. I recognize there might be some changes that have to be made, and that's fine, but we should see each of those changes as having like a cost, because it means it's harder for people who aren't like super deep in the process to understand what's going on. Yeah.
Very interesting. RIP is evolving process, I must say, and getting your insight on that. I hope it will be useful for many authors who are trying to propose something for rollup, as well as even for Ethereum improvement proposal. I know you have authored multiple EIPs so far, and including this one, this is one of the meta EIPs. I'm curious to understand what would you consider as the most challenging part of developing an EIP, and what has been the most rewarding part of your work on EIPs and Ethereum development?
I think the most challenging part of EIPs is anything substantial takes multiple years to ship, and people tend to come in the process thinking like getting my EIP done is like 80% of the work, and getting it deployed is the last 20%. Whereas it's the opposite. It's like getting your EIP to a spot where it could be included for most EIPs that are not trivial changes is effectively 20% of the work, and then iterating based on feedback, based on integration with other EIPs and whatnot, that's like 80% of the work. And so this is something I struggle with, like figuring out what's the right way to, one, yes, highlight that the process is open and that anyone can participate, but also two, set the correct expectations that like if you come with this huge EIP to change Ethereum, you should expect to spend like a couple years working on it. And again, this is open, anyone can do it, but then it takes a lot of time and resources to do this well. And so yeah, that's definitely the most challenging part, just like having to spend a really long time. And also that spending all this time is not like a guarantee that your EIP goes in. Like as you get closer and closer, sure, you get like a higher likelihood, but it's possible to spend many years and just work on something that doesn't work out. And like, this is a really, really hard thing. So yeah, that's the trickiest part of the process.
I understand that. I have seriously seen it firsthand. The other day, we were having a conversation with Alex Stokes for proposal 2537. With the proposal number itself, it suggests that 2537, that means it is very old proposal. Now we are at 7000 series. And it took about 4 years for that proposal to be included in an upgrade. But finally, we are seeing it over here. So yeah, it may take long, but people should not get discouraged. I think we want to be just very safe about any proposals to implement it on the mainnet. I know you have recently published a document on a process improvement on core dev side, EIP side, and breakout room and things like that. If you have to maybe pick up a few suggestions or ideas for EIP process, what would be your quick take from there that you could share with the community, where editors may be able to help improve the process, as well as anyone interested to participate in process improvement may be able to contribute?
The number one thing I'd like to see is better async discussion management. And the reason for this is that currently have ETH magicians as like the main place for discussion. And it's like this long forum thread with these really long running arguments that you have to follow super closely. And if you don't, you're sort of out of the loop. This is a really hard format for people to engage with that aren't like day in, day out working on that one EIP. And if you compare this to say, like just a normal like review model where like even like academic papers where like people submit something and then they get these reviews, I'd like the EIP process to look a bit more like that. Not that it should be like a paper, but that we have like this infrastructure that is able to keep track of like reviews and objections and concerns, even though someone's not on the forum every single day, like arguing about it. I think this has come up a lot in the past few years where someone has a specific objection to something and then they make it once and their objection doesn't get addressed and people sort of just move on. And, unless they sort of repeatedly show up, their point sort of fades into the background. So that would be my one like improvement that I'd like to see is like, how do we track reviews, criticisms, and whatnot in a really good way, and also track the stuff that's been like addressed. So saying there were all these objections and like here are all the PRs that fix it, or here's like the audits to prove that this is safe and things like that. So that feels like a whole chunk of like the process that's very ad hoc right now, and that would gain from being a bit more formalized, like the sort of review infrastructure.
Very interesting. I think I would like to share this piece with the editors, maybe in the EIP meeting or somewhere else async, so we can perhaps take a look into it. Thank you for sharing. I have just received a couple of questions in chat by some of the participants over here for you. What do you think about overall RIP progress, especially in terms of adoption by L1 core devs? Is there a gap in acceptance and understanding about the RIPs?
So I think the whole point of RIPs is ideally L1 core devs don't have to care that much. Like we don't want to block L2 development on L1 core devs. But that said, we still want to allow some amount of like standardization across L2s. So I think it's all still quite early and there's a lot of things to figure out. And feedback from L1 is valuable because if you eventually want your thing to ship on L1, you'd want to make sure there's at least some like enthusiasm towards it. But my fear is that we end up like blocking this on L1 and L1 is just really slow to do things. And what you see if it's too slow, basically if it's too slow, then people just do stuff outside of the process, right? They're not going to use RIPs. So yeah, I guess that's a question. Yeah.
I mean, maybe on a related note, like we are just trying to explore here. Do you think L1 dev should involve more to RIP building progress to decrease misalignment with rollups and decreasing the chance to spec changes when they want to implement it on L1?
Like, I don't think we should put it on L1 core devs to like do more in the RIP process. It's great if people follow it and get involved, but like, again, I really, really want to avoid blocking the L2 development cycle on L1. Yeah.
Yeah, I feel like coordination may be able to bring them in sync, but I totally understand there is a lot with L1 developers already on shoulder to maybe able to actively involve with the L2 development. Well, thank you for that. I'll wait for any more question coming up in the chat. But in the meantime, I have another question for you, and that is basically about this series. What are your thoughts on PEEPanEIP series? We have received quite good feedback from the developers community. They have mentioned that they are loving this series because they get to know all proposals in detail and may be able to ask questions with the author itself. And having this video form is pretty good and helpful to them. What are the things that you think we can add to make it better for client development team to make sure that this is one library we are creating here for anyone interested in learning about Ethereum ecosystem?
That's a good question. I think it's actually fine for PEEPanEIP to not be focused on client teams as the audience, right? Like I think it does a great job of explaining EIPs for people who have a little bit less context. And mine is a great example because it's a pretty trivial one, but any client dev can just read my EIP and understand exactly like the implications because they know what precompiles are. They have like context around all that. So I think it's much more valuable for PEEPanEIP to focus on how do we just explain what's being discussed on Ethereum to people who may not have as much context. And this way they can have like better understanding of what's being done on chain, but also potentially engage in discussion where it's like, okay, I didn't realize this is why that thing was important before, but now I actually have an opinion because I understand it. And aiming for that feels like the most important thing, even if it means that you lose a bit on the client audience because they already know most of this stuff.
That makes sense. We are trying to come up with some different talks, like not EIP specific, but in terms of research specific. For example, we are having multiple breakout room meetings and people are trying to come up with proposals in those breakout room meetings. But there is a pre-proposal stage where they are just discussing if this is something useful and maybe client team will be able to implement it. So I'm trying to bring up those kind of conversation as well. Like we are planning to have a call on ETH multi-call. So we would be sharing more information on that side as well. But thank you for advice. And we will try to include some topics which are not very, very technical, simple, but useful and informational for the community as well.
Yeah, awesome.
Very well. I know you are engaged with so many teams, work with so many different set of people. If you would like to shout out or give acknowledgement to any team or individual that you think are doing something more than development work that can help in community building.
Well, I guess especially because of the EIP we're talking about, I'll give a shout out to Carl and Ansgar who've been running roll call and trying to figure out what this process should look like for Rollups. So like that's a huge part of the valuable community work we have to do. So yeah, shout out to Carl and Ansgar.
Great. Yes, we tried to have Ansgar on one of the talks to maybe talk about what changes we are getting into Rollups side. And yes, it will be interesting to learn more about this initiative. People who aren't aware, there is a Rollup meeting that happens once a month on Wednesday. You can check out the meeting details on Ethereum protocol calendar if you would like to be a part of that. And if you are already a layer 2 project team member, you must join that call. That is very useful and it will help even this development team to learn more about your requirement and maybe shape up different proposals which could be used by other L2s.
Awesome.
Well, we are heading towards the end of this conversation. Can you share any advice for aspiring developers and contributors in the Ethereum ecosystem?
Yeah, I guess two things. One, to just become like a protocol developer, you don't have to actually, create new EIPs and stuff like that. A lot of the work is just, maintaining the actual clients and performance work and stuff like that. So I'm not being intimidated by like not knowing the details of every single EIP. And yeah, if like you have like strong experience outside of Ethereum, you can pick up Ethereum. It's not rocket science. And then I think if you are working on EIP, then trying to look at examples of successful EIPs in the past and like what they did, what the specification was like, what the like amount of testing was like, and all of those things. Yeah, that feels like a really productive way to go rather than just starting from scratch and not being sure what exactly to do or if you're doing things right or not. So yeah, trying to look at the previous examples is really valuable.
Very well said. One thing that most of the community members always mention is like you shouldn't be scared of anything and you can start wherever you are. Ethereum has a lot of resources. You can pick up right place, right forum to follow what you want to contribute to, and you would be able to collect as much as information possible. And other thing is don't hesitate to ask questions. You can join ETH R&D Discord, different channels, and there are so many developers to help you out with if you are especially interested into development and want to contribute in that section. Well, I would like to thank Tim Beiko for this wonderful overview of a simple yet useful meta ETH. Thanks to our podcast viewers and listeners for joining us on this special episode of PEEPanEIP. Remember, your involvement and feedback are crucial to shaping the future of Ethereum. So stay connected with the community, participate in discussion, and keep innovating. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum cat herders. Cheers.